We're looking at topic 15 review. This is the probability test you guys are about to take. Kind of roll through this. You roll a standard number cube 15 times, and these are your results. So this is an example of experimental probability because you're doing an experiment and you're getting results from your experiment. Based on your results, what is the experimental probability of rolling an odd number? So in an experimental probability, you have a proportion, the number of outcomes that you want, over the number of times the experiment took place. So we want, what is the experimental probability of rolling an odd number? We want odd numbers. So I'm counting 8 odd numbers. 1, 2, 3, 4, 5, 6, 7, 8 odd numbers over 15 times the experiment took place. So the probability of rolling an odd number is 8 over 15. Make sure that if you can simplify this fraction, that you do. Find the probability of hitting the shaded region. So for geometric probability, it's the favorable region over the whole region. The favorable region is the black shape. And to get the black shape, we have to do the area of the square minus the area of the triangle. So that's our favorable region, the square minus the triangle, and the whole region is the square. So I can figure out that the whole region, the whole black area is 100. That's 10 times 10. But I need to figure out what the area of this triangle is. So remember, the area of a triangle is 1/2 times the base times the height. So we have 1/2 times the base of 8 times the height of 6. 1/2 of 8 is 4. 4 times 6 is 24. So the area of the triangle is 24. The area of the square is 100. 100 minus 24 is 76. So the area of this shaded figure, the black area, is 76. And the area of the square is 100. So the probability of hitting their shaded region is 76 over 100, but you need to make sure that you reduce that as much as possible. So 76 divided by 100, and cut it in half and get to 38 over 50. Cut that in half again and get 19 over 25. So the probability of hitting the shaded region is 19 over 25 as our simplest fraction. On the calculator, it's still loading. You can type in control divide. Pretty sure it was 76 over 25. Sorry, 76 over 100. It gives you 19 over 25. All right, how many 4-letter arrangements of the letters M-A-T-H can be created if each letter is used only once? So a couple different ways to do this. You have 4 places to put a letter. There are 4 letters in the word M-A-T-H, so we can put any of the 4 in the first position, then any of the 3 in the second position, any of the last 2, and then times the last one. So if you remember, this is 4 factorial. Or we have 4 objects we are placing in 4 places. So any one of those combinations of math will give you the answer for this. I'm just going to type in 4 exclamation part, aka 4 factorial. And you get 24. So there's 24 different ways that M, A, T, and H can be arranged. 24 ways. Captain Sterno conquered 75 villains. Below are the origin locations from which the villain began. So we got 20 villains from the northeast region. We got 26 villains from the northwest region. We have 18 villains from the southeast region. And we have 11 villains from the southwest region. So what is the probability that a randomly selected villain is from the southeast? So Captain Sterno conquered a total of 75 villains, and they want to know what is the probability that he conquered a villain from the southeast. So there are only 18 villains from the southeast. We're going to check our calculator and see if 18 over 75 can be simplified, and yes, it can be. So 6 out of 25. The probability that conquered villain is from the southeast is 6 over 25. Captain Sterno is amazing. A football team holds tryouts with 10 players. How many different ways can they select the top 3 athletes? So select or choose the top 3 athletes. So for this one, order does not matter. So if you're thinking about using a permutation versus a combination, they're just trying to have any combination of 3 people. It does not matter what order they're picked in. So we taught you guys that it's going to be 10 choosing 3. You have to use your calculator for that application. Menu 5, 3 gives me my N choosing R. I have 10 items I'm trying to put in 3 arrangements, 10 choosing 3. There's 120 ways that you can select the top 3 people, or you can select 3 people from 10. So 120 ways that can happen. What is the probability that a randomly chosen point from line segment XY is on line segment AB? So we're looking for the probability of XY, and that's going to be the whole region or the favorable region over the whole region. What is the probability that a randomly chosen point from line segment XY is on line segment AB? So from line segment AB, and it's on line segment XY. So this is the part over the whole. The part is XY, the whole line is AB. So you need to calculate the length of each one. AB is 22 minus 7. It starts at 22 and ends at 7. 22 minus 7 is 15. XY, we have to count a little bit here. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And 17 minus 10 is 7. So the probability of selecting a point from XY that's on line segment AB is 17. 7 over 15. It is an unfavorable event. Suppose Duke has 5 different shirts and 6 different pairs of pants. How many different ways can Duke make an outfit? This is our fundamental counting principle. You have 5 different shirts times 6 different pairs of pants. That means that Duke can make 30 different outfits. This is not permutations or combinations because we're not selecting arrangements or orders for these things. Okay, Superman and Batman rolled a die 27 times. The result of the experiment were rolling a 5 a total all of 11 times. So based on their experiment, they did an experiment 27 times. And based on that experiment, 11 times the 5 came out. So the probability, the experimental probability of rolling a 5 is 11 over 27. Based on their experiment, what is the experimental probability of rolling a 5? Right here. But what is the theoretical probability of rolling a 5? So theoretically, a die has 6 sides and one side is favorable, the side that says a 5 on it. So we have a 1 in 6 chance of rolling a 5 on a die. The other letters A through Z written on individual pieces of paper. What is the probability that you randomly select a letter that is not a vowel? All right, so we have letters A through Z. That means we have 26 letters total. What is the probability to select a letter that is not a vowel? Well, the vowels are A, E, I, O, and U. There's 5 vowels. So if there's 5 vowels, that means that there's 21 not vowels or consonants. So what is the probability that we select a letter that is not a vowel? We have a 21 out of 26 chance of doing that. Again, check your calculator, make sure that it can't be simplified. 21 over 26. No, that's as easy as it gets. So the probability of selecting not a vowel is 21 over 26. There are 7 kids participating in a race. How many different ways can they place first, second, third, and fourth? So placement matters, order matters. We have 7 kids and we are placing them in 4 spots, first, second, and third position. So this is the same thing as 7 times 6 times 5 times 4. Or you can use the calculator to do 7p4. We'll show it both ways. Menu 5, 2. We have 7 kids and they're putting them in 4 different places. There's 840 different ways that can happen. Or if you do 7 times 6 times 5 times 4, there's 840 ways. Either method is correct depending on which one you're more comfortable with. So because placement matters, if Bobby gets first place or if Johnny gets first place, those are 2 different results. You have to use a permutation. All right, this is probably one of the most complicated questions on the test just because of the work involved in it. It says a dart is randomly thrown at the square board. What is the probability of not hitting the parallelogram? So in order for this to happen, for geometric probability, the bottom number is the total space you have, and the top number is what you want to hit. So we have a square, and we have to take away the parallelogram, and that's going to leave us with the shape. We're trying to hit the white region on this board here. So there are no numbers on it. You have to create your own numbers by counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this side is 10 long. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 times 9 is 90. That's the area of the whole region. The whole rectangle is 90. Now we have to look at the parallelogram. So if you remember the parallelogram, area equals base times height. 1, 2, 3, 4, 5. And I'm just going to count straight up. 1, 2, 3, 4. So 5 times 4 is 20. If I do 90 minus 20, I get 70. That's the area that is white. Okay, so the whole board is 90. The parallelogram is 20. 90 minus 20 is 70. Over the area of the entire region. And I have to simplify 90 divided by 70, or 70 over 90 is the number 7 over 9. So the probability of the event hitting the white region or not hitting the parallelogram is 7/9. A spinner is numbered 1 through 20, with each number being equally likely to occur. What is the probability of obtaining a number greater than 8 and less than 15 in a single spin? So we have 20 equivalent sections. That's our total number of outcomes. have 20 different outcomes. It says, what is the probability of obtaining a number greater than 8, but less than 15? So greater than 8, but has to be less than 15. There are only 1, 2, 3, 4, 5, 6 different results that are greater than 8 and less than 15. So 6 over 20. And 6 over 20 reduces down to 3 over 10. So the probability of getting a number that's between 8 and 15 but not equal to 8 and 15 is 3/10. How many ways can 4 cars be selected from 10 cars on a lot? It does not matter what order you select the cars in. So this is a combination question. You have 10 cars and you are choosing 4 of them randomly. What I do on my calculator is I usually scroll up to the last time I did a combination question and copy it, and I'll just change the numbers to the numbers that I need. So we have 10 cars and we're choosing 4 of them. There are 210 different ways to do that. All right, ice cream shop has 5 different flavors with 10 different toppings. How many choices are possible for a single serving with 1 topping? So you have 2 choices. There's 5 flavors of ice cream and there's 10 toppings of ice cream. The fundamental counting principle says you have 50 different choices possible. 5 times 10 is 50. This is not a permutation or combination. It's just options times options. All right, a survey of students in the auditorium is taken. 20 people are wearing green. I'm just going to write that down because it seems important. 30 are wearing blue, and 10 are wearing purple. What is the probability that a randomly chosen student is not wearing green? Okay, so we're looking for the people not wearing green. Now this one's a little tougher because they don't give you the total number of students in the auditorium. You have to add that up for yourself. 20 plus 30 plus 10. There's 60 people in the auditorium. And we're looking for not wearing green. So people not wearing green are blue and purple. There are 30 plus 10. There are 40 people not wearing green. So the probability of not wearing green is 2/3. Or 66.66%. Good luck on your test tomorrow, guys. Use this study. You'll be fine.